Welcome, a warm welcome to our first episode, so to say, from the Meet the Expert webinars. And I'm very happy to have a brave man here, which we put on on solo layout. I really want to thank you, Steve, not you personally, but also ABB for being our first guest in this new series. And yeah, maybe you can just shortly introduce yourself. I really want to thank you. I think
There's a
there's
little bit of
some,
background noise.
yeah, a little echo we had. Yeah,
Okay.
it's just underlining how happy we are to have you.
I'm really happy too. I have to admit, I've been watching some of your webinars and I really like this format, you know, this relaxed conversational style. And so when you asked me to join, I was really pleased to come on board. Obviously, we have to get used to this format as well. It's the first time to do it, but really happy to be with you today. And thanks everybody for joining. Quick introduction for myself. So my name's Steve Gibbons, and I'm a global market manager for continuous gas analyzers for ABB. I've been on a 20-year journey, so I've just celebrated 20 years with ABB just in June. And it's been quite a journey. I'm British, but I'm currently based in Frankfurt in Germany, and I've been around as well. I was in Japan for 3.5 years. I was also in the US for 3 years, so I've had quite a journey with ABB, and yeah, I've been in this role now for about 5 years.
Wow. Okay.
Wow.
That's so.
This is why we call an expert.
Yeah. I think this is something we can completely underline. And Jemson, allow me also to say hello to Singapore.
A hot, wet, humid Singapore. Say hello. Good afternoon from Singapore.
Yeah, that's great. And allow me also to say hello to everyone. And it would be super nice and super great to get your hello to the world. I thought this time we have more than 500 people signing up for this event. And I must admit, it increased the pressure. So the challenge is getting higher. But I must also admit, it's been so wonderful to see also the work, the preparation work Stephen and his team did. And I think it's going to be pretty exciting to see what he has to say about this, the point of view of an analyzer OEM, not just analyzer, but solution deliverer, so to say, and his view on the sample handling components, because that's at the end where all of this is coming together. Maybe some interesting detail. Jemson, can you show your can you show what you're wearing?
Oh.
Yeah.
What am I wearing? With my name.
This is very personalized. It looks very nice.
Are you wearing shorts? Are you really wearing shorts or no?
Don't tell people the secret.
Okay. I've seen that wrong. Okay. That's the interesting thing about
this. This is why I'm saying it's a hot wet system here.
Yeah, hot wet system.
I have to admit, I also had to dust off my suit this morning, so it's been a little while since I took it out of the wardrobe. So we're all having to adapt.
Yeah, that's true. Into the kind of new normal. Okay. No, but everyone, say hello from wherever you are. I think it's great to see this great community, and we are also super happy to have you here and to have you on board. Jemson, I think we have so much things to talk about, so much very interesting things to talk about. Can you share the presentation that I can just start with a very short overview of the agenda? So I'm going to put this to the screen. Yeah, it was working in the preparation. So there, I think it's coming up. If you go to the presentation mode, there we go. Great. Yeah, meet the expert, the meet the expert concept. As I told you already in the past webinars, or as we were discussing, many times we do get questions, not just about the application and the part of the sample handling system, because we have to be aware that the sample handling system is not just that it is just one component, but at the end, the analyzer system and the sample handling system have to be harmonized. They have to play together, and I think we're going to see some quite interesting facts also regarding the relevancy of the sample handling system in the entire analyzer system, because at the end we have to carry out a measurement, right? And we got many comments and questions to say, okay, can't we invite companies, analyzer manufacturer into this webinar? And so I'm like I said, super happy to have Steve here on board. And he will give a very good introduction, short introduction to ABB. We really focused on not doing a commercial tool here, but really give you some facts and useful facts. And I can also say, it's not going to be just PowerPoint. We will also have some live impressions, which is something we received from the audience, is a thing they loved. Yeah. And at the end, and I really want to invite you, I mean, we have this expert here on board. If you have any questions, just drop them. Would be nice to answer them in the Q&A session, and to have the chance there. Yeah, no, Jemson, that was good. That was a good move. Allow me just shortly to say, I mean, we want to make sure, or we are the friends of all analyzer companies. And also, I mean, there's components which are not delivered from us, but still we want to focus on the importance of sample handling in this context. And so I'm happy that in 2 weeks we have Siemens here with a little bit another focus more on this field of process measurements. And GC applications, and then we have NVIDIA at the end of the month. So super exciting. Okay, and I think now I talked enough, and I was taking too much time. And these questions were the questions at the end. The questions we are going to ask Steve about his opinion. Okay, so amazing. I press the right button, Steve, and I think your presentation is on. And
see if it works.
Yeah,
it's working.
Looks good. Yeah.
So yeah, I will start off just giving you a quick introduction to the portfolio. I wanted to start by talking about how we view solutions for analyzer systems, and this is what we call our value proposition. So for us, it's not just the products. High quality products is the foundation really, but it's also about traditional services and making sure that you have well qualified people close to where our customers are. And then the really fast moving development is around digital, and ABB is really pioneering digital software solutions. But today we're going to focus more on the products and then show you a little bit on the digital solutions. And I think we've got a demonstration for you as well, so I'm really looking forward to share that with you. Let me take you through some of the portfolio here. So obviously from your side, you would look at an application and you'd say, okay, we need to measure these components. So we look at that, and we then take a sort of shopping cart of different measuring principles to match that up with your application. And we have the benefit that we can pull from a very wide portfolio of all the different measuring principles that you can see. We also have GCs that are not mentioned here as well. That's one way of looking at the application. The other way that you can look at it is to say which analyzer modules are needed to suit the different applications. And if I look at our continuous gas analyzer series, you can see that this goes back many years, back to the 1920s. So the first thermal conductivity based analyzer, the Caldos, was invented by Hartman and Brown years and years ago for combustion processes. The Eurus was actually developed by BASF here in Germany, and it was licensed to Hartmann and Brown back in the 30s, and we productized that and started selling it commercially in the 50s in the end, and that's still our biggest selling product. It's a very well-known name in the industry. And then the other measuring principles you can see there as well: paramagnetic oxygen, you'll see a little bit on that later on, flame ionization, UV, electrochemical zirconia. And so that's really for us the foundation for all of our continuous gas analyzers. Going a step further then into the portfolio, what we do there is take, depending on the application, the different modules, and then we combine them into one of two different product lines. The first being the Easy Line series, or the EL3000 series, and this is all about value for money. So it's always the same high quality measurement, but this is now a simplified product concept, just giving you all the functions that you really need for an application. But you have a lot of flexibility there to combine two modules in one enclosure. The other product line is then Advanced Optima. Back in the 1990s was this product line was introduced, and what's so special about this product line is that it's truly modular. So each one of these modules can be combined in any combination. You can have multiple enclosures, up to 4 modules, 6 measuring components, but you can also extend it with PLC functionality, so different logic in there for controlling valves, performing certain calculations. You can program that to influence the IOs going in and out of the analyzer as well. So a lot of functionality.
Wow,
but obviously,
means, Steve, if I may ask, that means in the Easy Line, it's more kind of a basic version. It's a little bit our philosophy where we say, okay, the inside technologies are similar, but the number of options and the number of extensions you have are quite a little, or are more limited compared to AO.
Yeah, limited to really the things that you very often need, that you always need for an application. So we stripped it right the way down. So you still have quite a bit of flexibility, but not as much as the Advanced Optima.
Right. Okay. I got it. Yeah.
Yeah, but as today we're here to talk about sample handling, and we definitely value the sample handling system, and you'll see later on how much we value that. But so much so we have standard system solutions as well, which combine these analyzers together with all the different sample handling components into a system solution. So what you see on the right hand side there is the AO2000 system. So you have with that different probe options, filter units, sample line, into the gas coolers. We call it a feed unit with the pump and the flow meter, etc. There's a NOx converter in that version as well. This is generally cold dry, with the exception of the FID, which would be a hot wet version. That's what you see in the middle of the cabinet there. And all the signals, you can see these yellow cables, I think, in the background there. These are communicating all of the signals from the system back into the controller on the front panel, so that everything's operated from that front door. So that's the cold dry system. The other system solution we have is the ACF 5000. And here, instead of all the different modules, we really, the heart of the system there is the FTIR, and that's produced in Quebec in Canada. And we integrate that system here in Frankfurt. And we've installed more than 2,000 of these systems over more than 25 years. And this is really geared towards waste burning processes, waste incinerators, cement plants, but we see it extending out to other industries as well.
Okay, so if I very shortly jump into that or ask, so in the system you introduced before, the hot wet system here, there's a big difference. There's no cooler needed, right?
Exactly,
from our other webinars, we always talk about these 3 main components, like the probe, the heated line, and the cooler. And this was what you would do with the cold dry, you named it, right?
Cold dry is the AO2000 system, and then hot wet is the FTIR system. Yeah.
Okay.
Yeah, so the probe and the sample line are effectively the same. So we're typically always heating those to 180 degrees C, but the real difference is in the there's no real conditioning of the gas, just particulate filtration. And then you transfer that gas into the FTIR. There's an FID for total hydrocarbons, and then there's a zirconia sensor for oxygen.
Wow. Okay. So many special words, right, Jemison?
Yeah.
It's always super interesting. Okay, but that's the combination what you mentioned before, which is possible to be done in the hot wet. Okay, yeah, interesting.
Yeah, we'll come back to that a little bit later on too. So
great.
If you have questions later on, feel free.
Yeah.
Yeah. So beyond that, we also have solutions for hazardous areas. So if you're installing in Zone 2 or Zone 1 hazardous area, according to different regulations, different countries have different standards as well. We have two different approaches there. One would be an EXP, which is a purged enclosure. The point there is to avoid the buildup of any explosive gas mixture by purging continuously the enclosure. You'll see that in a minute. And then the other solution is EXD. So it's a flame-proof design. And the idea is that if an explosion took place inside the box, that it would be contained within the box. So two different approaches. And actually, at this point, I can take you to a panel that we have here where you can see those. And then I'll try and demonstrate that. So hopefully, yes.
We cross our fingers that you, oh, great.
So now I just have to navigate to that without tripping over a bunch of stuff here. So just give me a second.
We cross our fingers.
Okay.
Okay.
So I made it in one piece. Hello, everybody. So this, so this is a panel actually that we have in our training room. We've built up this training room to do virtual training since COVID, actually. So that's why we have all of this camera setup and everything.
Wow.
And just by chance, we have all of these different products that I was just showing you. So you've got the, this is actually a brand new product that is going to be launched in July. It's a FIDAS 24X system for measuring total hydrocarbons in Zone 1 and Zone 2 hazardous areas. So you can see the purge box on the side. And then you can see inside the box, we have the FID here, power supply, main controller board, and then your I/O modules. These are selectable depending on your needs. And then you've got a connection box under here at the bottom for all of your electrical wiring. And then these extra components here really for controlling the purge. So that's one product that we're, like I said, we're just getting ready to launch that next month. We also showed you the EL3060. So this is your EXD flame-proof enclosure. These two boxes here go together. So the top one here is your control unit, but inside there you can also have a paramagnetic or a thermal conductivity detector. And then if you need an infrared analyzer for measuring your CO, your SO2, etc., that's where we would put that module in this cylinder, and the two housings would communicate to each other. What's really nice about this solution is that you can operate through the glass. So it's got a capacitive touch. That's a difficult word to say.
Okay, yeah.
So you can operate everything through the glass. That's really nice. And the last one here is the
EL30. Steve, I'm always impressed how massive these components then are, right? I mean, all of this, all the protective housing. I mean, we have the same with our Zone 1 cooler, for example, right? It's always interesting to see how massive these components have to be laid out.
I mean, they have to contain an explosion. So obviously you have to build it to really handle that. So this is a very manly product.
Yeah. Interesting. Okay.
And then the other one here is the EL3040. I'll just very quickly open that box so that you can see. So this is for general purpose, but very compact. This is the Eurus 26 photometer, and then you also have under here a paramagnetic oxygen detector, so that shows you the combination of the two. And then again, the same electronics, but underneath here you have a connection box which allows this to go into an IP65 environment. So you could install this outside. It's a stainless steel box, very robust, and that often for customers is very useful.
Yeah,
good.
Sounds interesting.
I'm going to make my way back over there. See you in just a second.
Okay.
Wow.
Hopefully you will make it. Oh yeah, that's great.
Impressive.
There he's back. There he's back.
There you go.
Yeah.
So,
but Steve, let me ask you. I mean, this is new products you are releasing now. Do you also see, let's say a trending that there is more hazardous area measurements? I mean, we saw this in our product development. I mean, we released this new ATEX probe. And it's a little bit the feeling that even the measurements in hazardous areas are growing. Or
yeah, I think in general, yes. So maybe historically you could move the analyzer systems into a safe area, but then you compromise on the speed of the measurement. So more and more we're seeing the devices moving closer to the measuring point, and there you obviously get more into the hazardous areas, zone 2, zone 1, and that's why there is increasing demand. But I think there's also obviously a growing safety focus, and then there's more need to control the processes as well. So that's another reason why you would see an increase there in demand.
Yeah, yeah. But interesting, I mean, that would be the target customers for this type of application is probably not waste incinerator, but this is also going to chemical, petrochemical refineries, these directions, right? Yeah,
yeah,
okay.
it's almost exclusively petrochemical, chemical, with some exceptions. You might find applications in power if it's close to a turbo generator with high levels of hydrogen. But generally speaking, it's petrochem.
Yeah. No, I just found this, Jemson. I mean, you have some experience in the refineries back in your days when you were service doing, right? I mean, that's an interesting development when you, the sample handling has to be where it has to be. It's probably very often not possible to avoid the hazardous areas. But also for the analyzer, I think that's interesting, right?
Right. In particular, at this present time, I would say, there is a requirement. In fact, it's by legislation in mainland China. Yeah. In fact, it just started not too long. Particularly, there is a lack of hazardous area for the VOC measurement.
Okay.
Yeah. I mean, there are many people who can measure VOC, but the thing we're talking about, the true VOC, especially we talk about the EX zone, right? Literally, there's only very, very few supply can do that.
Yeah. Okay. No, that's just okay. Good. Yeah.
If you imagine that there's a flame inside this product, so that's the worst thing you could put into a hazardous area, of course. So it's not straightforward to do it. But there is a growing demand for it. Yeah, exactly.
So Steve is saying we should be thankful that we are just heating and not burning. I mean, we have just heaters in our products, and there's not a flame. We got it. Okay, yeah, but sorry for this detour.
No problem. Yeah. So I've got one additional slide here in this section. Just to close the story there. So ABB also offers a few different in situ based analyzers. So where the speed of measurement is really critical, or you have very harsh process conditions, that's where you might choose a zirconia oxygen probe for combustion control. That's generally the application for that, or blanketing applications is another one in the petrochemical industry. And then laser analyzers, of course, for very, very fast response, but it's also non-contact measurement. So they're ideal for very harsh conditions where the speed of measurement is very important.
Okay. Yeah, I'm very excited to hear your answer later, Steve, because I mean, this is always a big topic for us. Components like this, they need no sample handling system, which is not right. I mean, a little bit of sample handling also has to happen there, but yeah, I think that's going to be interesting to discuss later on.
Yeah. So at that point, I would move to new developments, unless you wanted to say something before.
No. I think it's thank you for this overview. First of all, I mean, it's always a lot of names, but I think it's very valuable also your overview to see, okay, what components can I measure with which technology, right? I think to get a brief overview. Because it's sometimes you only have one or two components to be measured. Sometimes it's more. I think that's a nice overview. Thank you for that.
Sure. Good. Then I would move on to newest developments. And here we have a couple of things to talk about. So the first one is, you asked me, for example, in the preparation, what about measuring technologies and what kind of innovations are taking place there? And here I would share the example of our Magnos 28. It's a fairly new product. We launched it in 2016, and it's using the well-known principle, paramagnetic principle, measuring oxygen. This measuring principle actually has stayed unchanged for 60 or 70 years. So the picture you see on the left-hand side is the Magnos 206. And this is, you can see the proportions there. That's the tip of a matchstick. Wow. And this is this is glass that's blown by hand under microscope by really experienced technical people. And it's really an art. That's why we call it a glass masterpiece, handmade glass masterpiece.
So
And that's the
it's
way it
really
stayed for
handmade.
60, 70 years.
Yeah,
Yeah, I
unbelievable.
mean, you really
Yeah,
sit
okay.
underneath the microscope, and all of the positioning, the fixings, and everything was done by hand. And these things are tiny. And we
Oh,
said,
God.
hey,
Okay.
come on, we need to move this to the 21st century. So
Yeah.
our vision there for the Magnos 28 was to replace this glass and all of the circuitry and everything. There's a mirror on there as well, and put that into but also then to automate the manufacturing. So that micro wing is positioned on the wire. It's bonded to the wire, and then there's these little hooks on the side that it's also bonded to, and that then is the complete sensor. And that's I'm not sure how well you can see this. That is the sensor there in a little plexiglass model.
Let me do the following. Let me put you on solo layout. Yeah. See,
Yeah.
we can see that pretty
still.
good.
Yeah.
Okay.
Super
Yeah.
tiny, but so these come on a silicon wafer. There's, I don't know, 200 on each wafer.
Okay.
Wow. But we're really excited about that, and it's particularly the reason it's so important is because every single sensor is the same, which means that when you get into very critical applications, very low concentrations or high concentrations, you get much better repeatability and precision on the measurement.
Okay. Interesting.
Oh, good. So that's the Magnos 28. I'll keep moving for the sake of time. The other area that you asked me to talk about was emissions and what's happening in terms of emission limits values in different industries. And I think the one that's most prominent, I think, is the BATC for waste incineration. And this is this will come into law effectively in 2023. Lowering the emission limit values for all waste incinerators or waste burning processes. So it could also apply to cement industry, for example, if they're burning alternative fuels.
This is Steve, just to give the people. I mean, we always see we have a big crowd also from other regions in the world. This is for Europe, right? This is the limits, and the discussion for Europe.
Yeah, thank you. So it's a European standard that may get extended to other countries, but it's primarily, of course, for Europe. Yeah. So what you see here is a significant reduction in the emission limit values for almost all of the measuring components. And the good news there is that ABB has already tested one of our ACF 5000 systems on a plant in Germany, in Ulm, and passed the Qual 2 evaluation with these lower emission limit values. So that gives us, we're very proud of that, but it shows, that it is possible to measure down at those limits. The next step, of course, would be to certify the system for those limits, and that's something that we're working on.
Steve, maybe a mean question, but do you have an idea how these limits are compared to other parts of the world? I was, for example, I was very surprised when we had an initial, or when I get in touch with mercury, for example, because the mercury limits in the US, for example, they are lower than they are in Europe. And sometimes we think, here in Europe, we have very high standards. But do you have an idea how these new ranges are compared to other parts of the world? Is that low or not so low? Or
I think these specifically for waste incineration are lower. So I'm not aware of any standards which are lower than this, but I agree with you. In certain countries, certain components, the regulations in the US are stricter. So I think for gas turbines in the US, the limits are lower. And like you said, mercury is another topic where the US EPA regulations are stricter than in Europe currently. But that will change, because the mercury limits will also come down in Europe.
Yeah. Okay. No, but I think the interesting point here is to see, and that was my question, or which we asked you, or pleased you to give us an overview what you think the future is going to be. Because let me outline. I mean, this also is a challenge, so to say, for the sample handling system, right? I mean, here in many webinars, James, I think you and I, together with Tobias, we showed what can be, how strong the effect can be from the sample handling system to the analyzer results. washout of SO2, for example. So yeah, I think it's interesting to see that only I mean, these great values which have to be achieved, or these new values which have to be achieved, can only happen if there is a good lineup, right? A good chain, so to say.
In fact, the measurement is probably the easier part with these lower emission limit values. It's really the challenges in the transportation of the gas throughout the entire system to make sure that it arrives at the analyzer in the right condition, particularly HCl, HF, ammonia, SO2 would be another one, because they stick, so they adsorb and desorb from the wetted parts. And that's a major challenge. It's already quite a challenge today, but with these lower limits, it's really going to push the limits of the system.
Yeah, okay, but that means for all of us, keep on developing, keep on working.
Yeah, there's no standing still. We have to keep moving.
Yeah, it's a driver, and it's a driver for a better environment. So yeah, it's great. Okay.
Yeah. So the last one here on this section would be a quick intro to the digital offering. And I'm going to do a demonstration in a minute for the dynamic QR codes, so I won't explain those in too much detail. Really what we've got here is the ability to easily transfer all the relevant diagnostic information manually. But like I said, you'll see that in just a second. So my Simon is here getting ready with the demonstration. The next one here is condition monitoring. So that takes the same diagnostic information and brings a continuous monitoring to it. So we continuously track all of these different parameters and generate health check reports for our customers so that they can keep up with the health of their system. And particularly in these lockdown periods, remote insights has been extremely useful. So remote support is quite common nowadays, being able to dial into the system and see what the customer's seeing, but you couldn't physically see the plant, you couldn't physically see the system, so you're a little bit limited. So what this does, this is a two-way video app, which allows us to sit in our factory or even at home, it doesn't matter, with the plant. So they would carry a smartphone or a tablet or maybe even a headset, look at the system. We see exactly what they see, and then we can overlay instructions to them and talk through those instructions as they're working through it. So that's been really, really useful. We were quite lucky, I would say, that we had that solution about ready before the first lockdowns came.
Yeah, that's what I wanted to outline. I think that's quite interesting. I mean, so many technologies have been there before, but it's nice to hear that now at the pandemic, people really made use of it because of no alternatives, right? So
you had no choice. Yeah, so we really were trying hard to keep supporting our customers, and it was tough. Yeah.
Yeah, but again, something very positive, I think, right? I mean, you have the chance to solve the problems maybe immediately, and I mean, we also have the experience if something is wrong with a sample handling system, depending on the plant and the operator. Yeah, you have people, they have to overwatch so many equipments, they cannot be an expert in the probe or if there's something wrong with the conditioning system, right? So yeah, that's nice to see.
The sample handling system is really the important part there, because if you have, say, moisture in the instrument air, or you have too much moisture getting into the cooler and it's not conditioning right, you can look at different parameters and have a sense of what's going on, but you can't really know unless you see it.
Right, I get it. Okay, yeah.
Okay, so we're ready here with our little demonstration.
Nice.
I just have to choose the right screen here.
Are we going to get our headphone ready?
Yeah, you could. I mean, this is the
getting my headphone ready to.
Okay, no, we're not going to do the remote insights. We're going to do the QR code demonstration. That would be good. So what you've got here is it's a remote HMI linked to the marine system that we're going to see shortly. So I can go through this menu here to generate the QR code.
This is a simulation, right? So
no, it's actually live connected to a system that we have here in the training room.
Oh, okay.
So if I click enter here, you see that it's generating the QR code.
Right.
Okay, we just lost the mirroring app. Just give us a second.
You just lost the phone.
The phone is still there. We just don't see it on the screen. So we'll bring that up in a second.
Yeah.
Yeah. In fact, you see, Steve was saying that, you know, as a threshold limit of the emission is getting smaller and smaller limits, you know, we always mention that the most underestimated component, which Steve has mentioned, is the heated sample line, whereby there is absorptions and possibility desorptions along the way, you see, which is also having the biggest surface area throughout the entire sampling component.
Yeah.
Yep.
Yeah.
So the beauty here is that QR code that you see on the screen is generated automatically with all the relevant diagnostic information. You can come to this with any type of QR code reader, and Simon is going to demonstrate that for us. So he's looking, you can see some of our training room here. You can see the marine system that we're about to show you a bit later on. And he can come to the QR code, scan that in. And what you see now on the screen is the initial, that's all of the coded information that comes out of that QR code. And I'll just pick out a couple of things there for you to see. So this is the serial number for the product. You've got the software version. It's got all the different analog. Okay, I think it's not so important. So what you can see there was all the coded information. And what's even more important for you is to see, that works. Okay, so this is when we receive it at our end, we can then decode all of that and generate a report. And this gives you some insight into what you would actually see in the report. So it's now fully decoded. It tells us that we have an AO2000 system with a Eurus 26 analyzer with the different software versions. You see there, for example, that the cooler condensate level is too high. So that comes from one of the status signals. It shows that we're in remote control status. You've got all the different I/O modules, the number of I/O modules. You've got the cooler temperature here, which is very useful.
Yeah. This is so interesting. It's so interesting to see, especially the information from the conditioning system. I noticed now in China, there's regions where they say, okay, that the authorities request not just the emission value from the system, but also information about the sample handling system. And that's just interesting to see that this is locked there, and that, I mean, it's a very valid, very important information, right?
It's hugely important, and for years we've had the approach that we need to have the data from the sample handling as well. So we have this CAN bus network that we build into all of the analyzer systems that take the signals from the sample handling components into the analyzer. And that's how we can get all this diagnostic information through the QR code from the display itself.
Oh my gosh, yeah, that's. I think we have to a little bit look at the time, but it's just super exciting to see.
So you can see with one shot, you've got all the relevant diagnostic information, and that really speeds up the whole fault finding, troubleshooting process. And even if you don't have a smartphone, you can take a picture with anything and just send us the raw picture. That also works. Then we can decode it on our end. So this is hugely exciting. What I would do now is come back to the presentation. And like you said, we need to be aware of the time here. And I would like to see you all as well. Good.
It's always super interesting. I think when you jump into one topic, you think, wow, I think we could talk just 1 hour about this, but yeah, okay.
1 hour is quite tight. It's a lot to cover, I know that. So let's move to sample handling, which I know is a topic close to your heart, and I know also for the audience here. So give you a bit of an insight into how ABB looks at sample handling. This is a typical cold dry extractive system that you can see. So you have the, not sure if you can see my mouse. So the probe,
we can.
The filter unit, the heated sample line, then you come into a valve or valves for calibration, the cooler, which is a key component of the system, with the peristaltic pump for draining that moisture off. Maybe an acid filter here if you have any aerosols that are getting through the system, that's an extra protection. Flow meter and a pump for transporting that gas, and then the final protection before the analyzer is a condensate monitor. And we quite often put another additional filter on before the analyzer. What's really interesting here is we did a study a number of years ago looking into the typical failures of a cold dry extractive system. We spoke to a lot of customers who helped us to gather data on that. And really interesting is that we learned 70% of all the upsets in the analyzer system are coming from the sample handling system. And of course, that doesn't mean that these components are not reliable and they keep failing. It's not that at all. It's because the system is not designed correctly from the beginning, or also that the maintenance is not performed correctly.
Yeah.
So that's important to mention, and I'm sure you'd like me to say that. And then when it comes to the analyzer, go ahead, Jörg.
No, really, Steve, that's great to have this number here. I remember I saw this the first time, I think in India, when Christopher Becker, from your colleague, did a presentation, and he shared these numbers, and I was really, wow. I just, this really outlines the relevancy, right? And I think it's, thank you for sharing this. It's interesting. Mm-hmm.
Yeah, and then on the analyzer themselves, 25% of the failures would come from the detector. So that could be optical components, it could be contamination in the cell. And then only 5% of the failures that you typically see are to do with the electronics. So It's really important to keep that in mind, and then also take seriously the design of the overall solution.
Right, yeah.
And for this reason, we also at ABB take it one step further in that we offer a pretty complete lineup of sample handling components. So on the probes, we have unheated probes, different grades of steel. We have a ceramic version as well. The heated probe, if you need to make sure that it's you're transporting that gas in the same condition. That's the probe 42. We have a number of filter units. Actually, I want to show you one of those in a minute, briefly. Different types of heated sample line with self-regulated fixed resistor heating, cooler feed unit, thermoelectric type coolers, and then we also have the SCCS, which is a Peltier cooler, but a fully contained conditioning unit. And then on top of that, we have NOx converters, a utility unit for power distribution, and a number of other accessories.
Yeah, Steve, let me ask you. I mean, that's what you said in the slide before. You said it's not because of the reliability of the components, but very often, and I think, Jensen, this is something you must celebrate, because that's what you always say. You say you cannot copy and paste a system. If a system works fine in this and this application, you might need to choose other components, right? So, Steve, is that the reason why you have a selection of different types here, or?
Yeah, I think there are certain elements of the system that you can apply to a very wide range of applications, but it's absolutely right that every application is slightly different. So there's always going to be a need to have special adaptations of that system to suit that particular application.
Okay.
But we also have we have different systems depending on the application as well, and you'll see that in just a moment.
Yeah, I'm just thinking how complex the solution matrix might be. I mean, we have the same situation with the heated sample lines, for example, right? I mean, it's so many different configurations which you can have. That it's sometimes it's really a challenge to choose the right components, right? So I can imagine even for your team, there's a lot of experience also needed, right?
Yeah, I mean, we have an application team here in Frankfurt that supports the local organizations for specifying the right solution for those applications. And these are people with 30, 40 years of experience, and you need that sometimes.
Yeah, sure. Yeah, okay, Thank you. Yeah.
Okay, I'm going to go to the PFE2, which I think you'd be interested to see. So this is one of our probe options, and now I'm going to move over there to that one.
Okay.
Does that work?
Yeah, it will work. I did a wrong selection here. Full screen layout. Okay, your head is cut it off, Steve.
That's okay.
But
you don't need to see my head.
Remember.
More important is the product. So this is the inside. So you can see big heavy duty stainless steel box. The sample line comes in from underneath and connects to this this valve here coming into the filter unit. I won't demonstrate that now, but it's very easy to turn this and pull the filter element out for cleaning or for replacement. And then what you have around here is the back purging system. So very heavy duty pipes, which means you have a lot of power there for the purging, and you can purge from the inside and also the outside of the filter to make sure that it's really clean. Yeah, I would not say too much more about that. If you guys would like to comment, feel free, but I'll make my way back to the other screen.
Yeah, no, I think it's just very nice to see. Yeah, I mean, there are some things we heard from you now. Yeah, which we always say. You know, it's important. I mean, especially the probe. Yeah, the primary filter unit, because it seems like the philosophy is a little bit similar, that everything you are not getting into your sample handling system, which can remain outside, the filtration and very efficient filtration, and also low maintenance, which is what I understood from the back purging. And yeah, I think it's interesting to see.
Absolutely, and we like this concept very much with the heavy duty back purging. We don't see any other solution out there that's quite as robust and suitable for those challenging applications.
But at the same time, a little bit comparable to the concept of advanced Optima and EasyLine, you also have different options there, right? Because I mean, I think it's important to say that if you have a super clean measurement, I don't know, a gas power plant is something which pops into my mind. You don't need to have this fully equipped probe system, right?
That's where the PFE3 is ideal, because it's self-regulated heating. Okay, you can equip it with the back purging, but it's very often not necessary, and that's a smaller box. And of course, you save some money too there. You don't want to spend money unnecessarily.
Yeah, I think that's interesting. Yeah.
So I would come back and continue on the track here. So we talked about cold dry systems. And now I want to share an example here of a hot wet sample handling system. So this is very similar to what we have in the ACF 5000 system. Really the challenge here is you need to have every single component of the system heated to 180 degrees C, which sounds pretty simple, but in actual fact, it's very challenging to do properly. So if you had all of these different components, each with their own heating and insulation, it's really not easy, and it's very difficult to maintain that system as well.
That's a little bit surprising, right? Because I mean, if you look at the it's not a PNID, but if you look at this graphical overview, I would say, hey, this system should be way easier because you don't need a cooler. So there's one component left. It will only cost half of what the other system costs, and so the challenge is the interfaces, or where do you see the biggest challenge? Steve?
Exactly. So the keys here for designing the system are, you've got to make sure, of course, that the temperature is maintained, but the art form, if you like, there is to limit the number of connections between the different components of the system, make sure that the distances between those components are also minimized. Really take a lot of care about any parts in the system that are going to wear, because you're at a much higher temperature. So diaphragms and O-rings, you need to carefully select the materials there. And then if for whatever reason the system is not maintaining that temperature, then you have a risk that you put an unconditioned sample all the way through to the analyzer. So you need some protection measures in place to make sure that the analyzer is protected if the temperature is not maintained. So the ABB solution there, this is an example from the ACF 5000. I won't talk you through all the details here, but that's the schematic. And really the heart of this system is what we call the ASP block, which is an aspirator block. So you have in there an injector or an inductor. So it's no moving parts. We use instrument air to create a vacuum and pull the gas through. But this piece is, this whole block is machined out of one piece of metal. A lot of engineering involved, and that's really the key to making a hot wet system simple but also reliable.
Right, I got it. So the first part, probe heated line, and then you already have the connection to this ASP block, to the
exactly direct connection into the block, and then you've got a filter here, flow control. You've got the zirconia cell, the FTIR, and the FID. So that
Okay.
in the end, it's very simple, but it's not simple to realize. Of course, you have to put a lot of thought into that.
Yeah, and I think it's also interesting what you say because I mean, you are delivering these systems worldwide, right?
Yeah, exactly. So
you have a
2,000 of
temperature
these systems.
range. Yeah, so you have a temperature range from, I don't know, -20 somewhere up to yeah, measurements where it's very hot. So
Plus
yeah.
50. Yeah.
Yeah, I would think it's interesting to see. I mean, it's super complicated, these analyzer systems and these analyzer solutions. But yeah, then you always also have to face, you know, the environment conditions, and this can sometimes also be tough, not to get a too high temperature. Because the temperatures you mentioned there, Steve, 200 degrees C heating, for some components, that's already coming closer to the limit, right? So
Yeah,
yeah, that's a challenge. Okay.
it certainly is. Good. So you mentioned before about different solutions for different applications. So these are the 3 standard system solutions that ABB offers. One is the easy system. So this is really for measuring CO oxygen in crematoria or small boilers, that type of thing. So you can really simplify the sample conditioning down to standard components. And this is a plug and play concept that ABB has, where you really just take these different modules and put them together. The AO2000 system in the middle there is more towards power plants, iron and steel, pulp and paper, and maybe certain applications in the chemical industry as well. And then ACF 5000 is the one that we just mentioned, which is for your waste burning processes, measuring a long list of components, and that's a hot-wet system design. That's the what would you call it? That's the high-end solution, let's say.
Yeah, the multi-component, all-in-one, so to say, for this
Exactly.
type of measurements. Yeah, that's interesting to see. Yeah, no, thank you for sharing this. I think what is super interesting. I mean, when we had the preparation here, and I think that's a topic which is touching our whole industry, our niche industry, is what will be future measurements? Because if you mention now, Steve, okay, the easy system, for example, for small boilers, and then we talk about the AO2000 system, for example, for also power plants, coal-fired power plants. We see the developments here in Germany, we see the developments in Europe, and we see that, yeah, the decarbonization of the world is a big topic, right? But I found it quite interesting that you said, okay, if I have the chance to present another innovation from us, you choose an industry where most likely this will, yeah, still have to use oil even in the future, right?
You're talking about the shipping industry, I guess.
Yeah,
exactly. I think the shipping industry was a little bit off the radar for many years because, you know, what's out at sea, people didn't seem to think that was as critical. But of course, the emissions are still going into the atmosphere, and I'm really pleased that there are now much stronger controls there to limit those emissions. The initial focus is on when the ships come into what they call emission control areas. So that's close to where people are living. But I think going forwards, it will also extend to what's out at sea. So if the shipping industry wants to continue burning diesel or heavy fuel oil, then of course they also need to make sure that the emissions are controlled. And that's why scrubbers are becoming much more common these days. And I actually have a solution to show, which we've just been doing a training for a major scrubber manufacturer. And so by chance, we have the system all set up here, and I wanted to just quickly talk you through that.
Yeah, I think it's just super interesting to see. Yeah, this even in this industry that there is new applications coming up, right? And yeah,
it's never boring. It's never boring.
Yeah, which is good.
It's good.
Okay.
Keeps us busy.
Okay, again, Steve, I think we will not see your head.
No, that's okay. I think you have to look at my legs, unfortunately. But let me just
Okay.
revert there.
Okay.
The resolution there is not great, but
We get the idea. We get the idea.
Okay.
I think.
So this is a system called the SEM Captain. So this is my hand. You just saw Simon's hand here.
Yeah.
So it's very much the same concept as the other systems that we showed you, except that we've really built it into a more compact system specifically for the ship, and you'll see in a moment some of the modifications. What's nice here is that the analyzer pulls out on a rack here, so if you need to get in there for maintenance, that's very useful. You've got an extra door here which you can also open for maintenance, which is also useful. There's an Ethernet port for service, so if you need to come in and connect up your laptop to communicate with the system, that's very easy. And then you've got the cooler and the feed unit here at the bottom. I would then switch to the side view. Just give me 1 second. Simon, can you hit that one for me?
I'm quite impressed how smooth that runs here.
We have a little control panel. It's pretty nice. So now what you're seeing is the side. So you can see this door on the side. And what you can also see at the back of the cabinet is the vibration mounts, the dampers. So that's something very important for the marine industry because you're faced with much more vibration. So these are selected very carefully depending on the frequency of the vibrations that you would have on board the ship. Okay, now I've messed it up for Simon because first of all I was supposed to show you the inside of the cabinet, but he's going to zoom down for us. So this is now the side of the cabinet, so that's also very nice for maintenance. I mentioned before these yellow cables, perhaps people didn't remember that. You can see them at the back here, these yellow cables. Yeah. And this is a CAN bus network. So the sample handling components are connected into this CAN bus network. And these same cables come up through the system and connect to the back of the analyzers. And that gives us all the diagnostic information for the sample handling as well as the analyzer in one place. So that's really, really useful because it gives you that visibility into everything that's going on.
Yeah. So the entire size of this cabinet now, Steve, is this comparable with any other system, or?
Yeah, maybe the easy system that you saw, the first one. So, it's a very similar size, so it's about waist height, at least for me. But I'm relatively tall, so keep that in mind as well.
Yeah. Okay. No, that's
good.
That's interesting to see. So it's not just the requirement again to come to our point of the sample handling system at the same time. So the sample handling system has to work on the ship, and obviously the analyzer, and all of this is combined in one system there, right?
Yeah, and obviously the shipping industry is not used to analyzer systems, so making it as easy as possible for them is key. That it basically tells you what needs to be done, and then you can easily transfer this diagnostic information back.
I think that was interesting when in the preparation here, when we had the discussion about these shaker tests. Once I had the chance to attend one of these shaker testings, and it's just impressive, right? How high how high the requirements are, right? I mean, but it's all about safety, and I think the numbers show also in other industries how important this is. Okay.
Yeah.
Great.
So that's the end of my presentation.
Wow.
It'd be great if there's some questions. I know that we're a little bit out of time, but I hope that some people wouldn't mind staying on for a few minutes longer.
Yeah, but first of all, Steve, thank you. If we would have betted at the beginning, if you can make these slides on time, I mean, we tried our very best to avoid you from being successful in this, but no, okay, just kidding. I think, that was a great overview to see current developments and to see the importance of the sample handling systems. So, let me have a look if we do have any questions. In the meantime, I would like to ask you our top 5 questions, which are related to the topic of sample handling. So maybe first of all, Steve, the most underestimated component in the sample handling system from an analyzer manufacturer point of view, that would be interesting for us.
Yeah, I mean, I know that the cooler is a key component of the system, and I've seen in previous webinars that you've done that's a key focus. But I would actually say the most underestimated is the probe. You know, if you're trying to transport the gas out of the process and keep it at a certain temperature, any of those connections to that probe are absolutely critical to keep hot, to make sure that the gas maintains the same conditions as it is in the stack. So I would say the probe. Or the probe and the filter unit combined.
Okay. Okay. I have one question here from the crowd, and allow me to just move this there. Mr. Bostan was so nice to ask this question. Which is the most preferred for SEMS, hot wet or cold dry? That's a good one.
It's a good question. I think you could look at it from a technical point of view, or you could look at it also from a pricing point of view. And I think price, of course, is also an important topic. So I would say where possible, I would say cold dry is still the best choice. The real advantage there is that there's much more that the plant can do to maintain the system themselves, but also the price level for a cold dry system is lower than a hot wet solution. But if you need to measure reactive gases like HCl, HF, ammonia, or moisture as well, that's when you would move towards a hot wet system.
Okay. Yeah. Thank you for this. So we have another question from our question list. Stephen, your experience, what would you think the most common mistake? So if people are watching here, what would you recommend to them?
Yeah, I would think, well, to be honest, one of the things we see very often is that is the overall cost of the ownership of the system is not fully appreciated at the beginning. So the initial purchase decision is very often a cost-driven decision, but that can also mean that later on you suffer because of more maintenance required, failing components that ends up costing you a lot more. So that's a very common one, but of course also in the design of the sample handling system that, like you said, Jürgen and Jameson, that the copy and paste approach doesn't often work, that you really need to make sure that system's customized for that specific application.
Okay. And I think one is very clear, to select the wrong supplier is one of the most common mistakes. Okay, just kidding. Okay, yeah, then let's have a look here. How do you see the future? What do you think? I think it's also, I mean, especially for us, it's a very important question as we produce sample handling components. What would you say? It's a little bit similar or comparable question to hot, wet, cold, dry, about extractive, analyzer, and in situ measurements.
Yeah, well, I think the in situ measurements, they have their place. So if you're measuring a few components in harsh conditions, harsh process conditions with high temperature, high pressure, corrosive gases, and maybe the speed of the measurement is very critical. That's where in situ fits. But if you need to measure multiple components, and then you also need to perform maintenance on the system quite frequently, especially for emissions, where you have to calibrate or at least check the drift of the system regularly, that's where extractive for me is still going to remain the choice. And we see statistically, it's 90+% of the cases that extractive measurements are chosen, exactly for the reason that it's so much easier to maintain them in a nice clean environment.
Okay, Jemson, this is good news for us. No, okay. All right, last question, Steve. And I think then really we should come to an end, but I like also to have a little bit this point of view. I mean, our industry, the emission monitoring, I mean, today we focused a lot of emission monitoring. We know that the world of emission monitoring and process measurements cannot be fully divided, right? But still, what is the ABB point of view on which role we can play to achieve the reduction of emissions?
What we're seeing right now is a massive shift in focus towards circular economies or sustainable operations. So how can you decarbonize typically heavy polluters is the wrong thing, but industries that by the nature of the process produce quite a lot of CO2 emissions. So there's a huge activity towards hydrogen, green hydrogen, electrolyzers powered by renewable energy. And then also the importance of introducing oxygen into certain processes so that you have a much cleaner combustion and a much purer exhaust stream. And analytical measurements are going to play a key role there in controlling those processes, but also then helping industries like cement, iron and steel, petrochemical industry to decarbonize. So I see the role of gas analyzers very important in that, and then there'll be the traditional measurements too. So if you add, for example, carbon capture and storage to some of these processes, you'll also see additional measuring points there for analyzers as well that will be critical to control that process, but also critical to make sure that what comes out of those processes is clean and safe for the environment.
Yeah. Thank you for sharing this. Okay. Yeah. Wow.
A lot to take in. Hopefully it wasn't too much for people.
No, I don't think so. At least I can say we enjoyed this a lot, Steve, and I'm very thankful that we could invite you as our guest today. Wow. Just by running through it, there are so many parts where I think, hey, we could have just a webinar about a certain topic about in this. But let's see. I think for everyone, it would be great if you can share your comments, how you like this, and so that we get an idea. And Steve, I hope you also enjoyed this.
I really did. Yeah, thank you very much. I really appreciate this opportunity.
Yeah, and I think maybe we see us again.